Assalamu alaikum. In the first of all, my name is عروب ضميري and my supervisor is Mr. Muhammad Musa. And I'm here to introduce my project, which is a numerical solution to the elliptic partial differential equation. Introduction. What things that I should have to solve elliptic equation by using a numerical method. Here I have Poisson equation, which is called like uxx plus yy equals 0. This one is called a Laplace equation. And I'm going to solve this one Poisson equation by using a Dirichlet boundary condition, which given as uxy equal gx for all x and y belong to S. S here is the boundary of the rectangular region. The research problem. If the temperature distribution on the boundary of the region is known as a Dirichlet boundary condition, what is the temperature within the region? This is what I'm gonna solve today by using a numerical method. What is the solution? In the first of all, we should determine the step size, which is x b minus a over n, this one for x-axis, and k equal d minus c over n, this one for y-axis. And then I'm gonna partition the interval a and b, this one for x, on n bars and with width h, and do the same one for y-axis in the interval c and d with width k. In number 3, if place the grid on the rectangle R by drawing the vertical and horizontal lines through the point with the condition xi equal a plus ih for I equals 0 to n, and yi equals c plus gk for j equal from 0 to m. Note that the lines are called grid lines, and the intersection between the lines are called the mesh points. Here are shown in this figure, the rectangle what I want to have the temperature inside those. Those are the boundary condition with the Dirichlet formula, and here the grid lines, and I have those one black, those are called the mesh point, the intersection between the grid lines. Then in this formula, this one we're gonna use a Taylor series for two variables. I don't write the explanation, but I write the final one, which is this one, I'm gonna explain this one. Wij is u xi comma yj. It is the approximation for this one, and I'm gonna solve it by an example, but I'm here just gonna show you the formula. And this formula is just used for I equal 1 to n minus 1 for the interior point, and for j equal 1 to m minus 1. Also this one for x-axis, this one for y-axis. And for the boundary condition, it's known as the Dirichlet formula. Ux naught yj equal gx naught yj, and uxnyj equal gxnyj for j equal from 0 to m. And here also for the second axis, uxi y0 equal gxi y0, and also y un for gxi un for I equal 0 to n. And the last step. In this method, by using that method, we have n minus 1 cross m minus 1 cross n minus 1 time m minus 1 linear system with with an approximation wyij to have the interior mesh point. I have here an example. Consider the problem of determining a steady state heat distribution in a thin square metal plate with dimension 0.5 meter and 0.5 meter to adjacent. The boundaries are held at 0 Celsius, and the heat on the other boundaries increasing linearly. This one is called a Dirichlet boundary condition. Linearly from 0 Celsius to 100 Celsius, where the side meet. If we place the sides with the 0 boundary condition along x and y axis, the problem is expressed as this one. In the first one, we write it as we speak, but this one is written as mathematical formula. Uxx plus uyy equals 0 on R. This is the region, the rectangle, x from 0 to half, and y also the same, with the boundary condition u0y equals 0, ux0 equals 0, ux 0.5 equal 200x, and also the same for y. For n and m equal 4. This is given from the example. And here's the figure for our problem. Those are Dirichlet boundary condition, and what I'm gonna do, I'm gonna solve and know what is the temperature here in those points. B1, B2, B3, B4, and also. Solution. First step, we should find H and K value, which is equal to this one here. Those are called step size. Then using the previous formula and substitute H and K in it, and it's gonna have this one here. And from this, we're gonna have a linear system as it's shown here. This one, point 1, I got from point 1 those, and I'm also from point 2 the same and the same one, and also substitute until I reach the point 9. And those one here, okay, those are the boundary. I know the solution for them. And those the interior which I should determine. And those are boundary conditions are known from the question. Here I write the previous formula as a matrix, and I'm gonna solve it. Maybe I can solve it directly by using a numerical solution, but maybe sometime it's gonna be very hard. Because of this, I solve it in Gauss-Seidel method. But here is the solution. Wi equal this W1, W2, W3. As a previous figure, we have here point 1, point 2, point 3. Those are W1, W, and etc. And for this formula, Uxy is known because it's a Laplace equation, but the error here is 0, since we have the formula here Uxy. if you بما معنى انه اذا اشتقيتها للدرجه الرابعه راح تطلع الاجابه 0. And thank you. I'm finished. If anyone would like to ask any question, please welcome.